All right, so we're going to talk about workability of concrete. Real quick, before I get going, just so I have an understanding of who is represented in the crowd, how many contractors do we have? Okay, that's a pretty good number. Engineers? A little bit more, makes sense. And then who am I forgetting? I doubt there's any architects. Are there any architects? Oh, there's one architect. Oh boy. Well, we're you're outnumbered, buddy. Yeah, that's about right. Okay. How many owners do we have? Yes. Okay. Yeah, students. We have students. All right. Okay. I'm done asking questions. All right. Okay. We'll blue collar this one. So for the contractors in the room, you pop the forms one morning and you look at this. So the question I have is, how do you react? If you look closely, what you'll see is some weird voiding and then a very large void at the base, indicating evidence of form leakage. And so what do you do? So for the contractors, has anybody in this situation gone ahead and put the forms back on? Yeah. Wait till no one's looking. So if we think about workability, so I did this yesterday. I always said, what is workability? I'm going to give a talk on workability, and so I Googled it. I mean, that's what we all do these days, right? Folks my age and maybe older, when you were a kid, you looked at things in the encyclopedia, but we have Google now, and so you Google it, and you don't just get web pages these days. You get the artificial intelligence, and so it says it gives a definition according to the American Concrete Institute. I don't know. And so it's the ease at which something can be mixed, placed, and consolidated and finished. And so when is workability important? Maybe in a situation like this, right? As an engineer, the one thing that we really love is we love our rebar. We love our rebar. And we put it on the paper, and you know, interestingly, that's not how it looks on paper. But then when you start putting all that stuff in there, it kind of looks something like that. And so the question is would our 4 to 6 inch slump be appropriate for that type of element? Maybe, maybe not. Workability is important for flat work, right? For the engineers in the room, how many folks specify a 3 to 5 or a 4 to 6 inch slump for your flat work? Oh, nobody's going to admit it? Okay. I'm sure all of you are specifying an 8 inch slump for your flat work. No, that's not true. I think any engineer that's specifying a 2 to 4 inch slump should be required to rake that concrete. I myself have once raked a 2 to 3 inch slump, and I thought to myself, dear God, this is horrible. And I walked over to the ready mix driver and I said, let's add about 30 to 40 gallons of water. This is a little tight. So workability is important. And so if we read the end of this definition, according to the artificial intelligence provided by Google, it says slump of concrete is a standard way to measure its workability. How many people in the room agree with that statement? One person, two person? A few of you in the audience, I'm sure, are smart enough to know that I'm baiting you, right? Because for those of you that have raked concrete before, know that not all slumps are the same. A 6 inch slump is not necessarily the same, and so it depends, right? It depends on your rock, it depends on your sand, it depends on the proportions of that aggregate, right? And so you can have a 6 to 7 inch slump with limestone, and that's going to perform and feel a lot different than something with river rock. The river rock is going to be easier to move around. And so what does slump actually mean? What is the point of slump? I mean, we think about slump and we think of that and how it relates to workability. And so the history of the slump test method comes from a guy named Roman at the Illinois Department of Transportation, IDOT. Well, what will become IDOT? And so the idea that he had was at that time, they had a tough time controlling the water content of mixtures on the job site because they hadn't figured out how to adjust for moisture content of their sand and their rock. And so he had this idea of coming up with a simple test method to keep the water consistent from batch to batch. And so his idea is can we determine and detect uniform changes in the amount of water of concrete? And so he came up with this idea of a cone, and to come up with the shape of the cone, he tested different shapes. So he tried a bunch, including, if you look on the left, he actually used a 6x12 cylinder, and that was kind of one of the early bases. And so he tried various different water-cement ratios, and the idea that he wanted was if you change the water content, that slump value would be have a linear relationship. So he tried a bunch of different sizes, and what he found is that a 4x8x12 cone makes the most sense. And so that's what we have today. So we've advanced a lot since 1922. What are the problems with the slump cone and the slump test method? So this is interesting. So if you look at ASTM C143, and there's a precision statement in the back of the test standard. And what you'll find is for a 6-inch slump, you can have 1.5 inches of variation for the same wheelbarrow of concrete. Let me repeat that. For a true slump of about 6 inches, it's perfectly permissible and reasonable to have a difference of 1.5 inches. So what does that mean? That means Karthik can pull a slump cone, and he can get a slump of 6 3/4 inches. I can pull a slump cone and get 5 1/4. And that is perfectly acceptable according to the precision statement of the test method. So, what's that? Yeah, so Karthik pulls it 6 3/4, I pull it 5 1/4. For 4 to 6 inch specification, everybody loves me. We're having no problems with Jacob. Slump is good. What's the deal with Karthik? Doesn't he know how to pull a cone? It's out of compliance every time he pulls that cone up. And so that's a problem because most of our slump specifications, right, are a 2-inch range. That doesn't necessarily encapsulate just the differences in the operator. So let's look about this for a second. This is a real project. This is real data. Okay. This is a project I worked on about 10 years ago during my testing lab days. And so I get this email from the architect. And he says, why do we have all this non-compliant slump data? We had sent them out a new technician. We didn't have this problem with the previous technician. And I'm like, okay. So I look at the data. So we have a few data points that are not within that 4 to 6 inch requirement. And so I said, well, let's plot this. So here's a control chart. And so what you see is just slump on the y-axis as a function of each individual sample. So we have approximately, I don't know, almost 60 samples. And so I said, okay, what does this mean? So I was like, well, let's plot this on a frequency distribution. And so for those of you that remember from our statistics class, our sophomore year in college, the interesting thing about data is most of our data is a normal distribution, right? So if we plot this data, we would expect that something should be something like a bell curve, right? We're all familiar with the bell curve, right? Our A's are in the top 10%, our D's in the bottom 10%, right? And most of us are getting C's, and we're stuck right there in the middle. There's nothing wrong with C's unless he's the engineer of record on your project. So we plot that data, and so this is kind of what it looks like. And so this is our new technician, and it sort of looks like a normal distribution. It's not perfect because it's real data, and real data isn't perfect. And so I said, well, this data seems perfectly reasonable. I don't think there's anything wrong with this new technician that we've sent out to the job site. But then I started thinking, what about this previous technician? What is that guy doing? Were his results too good to be true? So I plotted his stuff on a control chart, and I remember there was one day that I went on that job site for about 30 minutes. That happened to be the one day when he had a 9-inch slump. A little weird, but doesn't necessarily mean that he's doing anything wrong. So I plotted his data on a frequency distribution, and this is what I found. Part of his frequency distribution is missing. And if you look closely, what you'll notice is it abruptly stops at 6 inches. Does anyone want to know what the specification was for this particular project? 4 to 6 inches. Oh, but wait. Let's take a little bit closer look at this. And so this project was in the great state of Texas. And for those of you that know Texas, it doesn't freeze or thaw. And so even though we have air content that we measure, it doesn't really matter. There's typically not a specification. So there's no reason that this individual, this technician, would have any reason to manipulate that test data. So let's plot his air content data. And what do we find? A nice frequency distribution. So that slump test that we use to judge workability, how important is it? When we talk about slump, what are we actually talking about? We use slump oftentimes interchangeably with rheology. We don't use the word rheology because it's a fancy word by academics, and we're like, do we really know what that word means? But rheology is how that material moves, right? When it's given stress. So let's talk about the eye test. See if I can get any of these videos to work. I want all of you to look at this concrete. It's dripping off the fence. I'd love to rake this concrete. I think it'll slide right into place. All right, we'll watch one more. Okay, so does this concrete pass the eye test? How many people would like this concrete poured out on their job site?
What's the application?
I don't know.
Am I running 30 stories straight up? Or am I putting it around all that rebar and big basement? Like what?
It's not a sidewalk. So this is actually a foundation mix.
It depends on it. If this is up because of that mixtures
Okay.
or water,
Well,
slope test doesn't really take the elements.
yeah, it's a little tricky, isn't it? So I see a few hands that are kind of like, I think I would. I'd put it in my back patio concrete. I'm not sure I'd put it in a column form underneath my condo on the 30th floor. And so we see it dripping off the fence, right? What else do we see? Aggregate is still in suspension, right? So that's a good sign. So this is probably pretty good concrete. But when you think about workability and slump, what are we really trying to do? We're trying to get the concrete into the forms, we're trying to cover up all the reinforcement, and we don't want it to segregate it. And if we can accomplish those three things, we're probably doing pretty good. And so oftentimes during a project, the question becomes, do we need self-consolidating concrete, right? So what does slump flow measure? Probably that's the safest answer. Let's watch. So these are all fun videos to watch. These are examples of things not to do. All right. Looks a little soupy, looks a little wet. Just so you know, the slump cone is supposed to be pulled up a distance of 9 inches over a time period of 2 to 5 seconds. 2 to 5 seconds. 1 Scooby-Doo, 2 Scooby-Doo, 3 Scooby-Doo, 4 Scooby-Doo, 5 Scooby-Doo, 6 Scooby-Doo. There we go. There's the 9 inches. So that is an example of things not to do. This is another fun one. You can actually hear me in the background because I'm getting a little antsy. You should also not strike off the top of the cone or the bottom of the cone, depending upon how you preference. The anticipation is building. I can feel it. Keep going up, dude. So that's me yelling at him. It's like, okay, here we go. All right. So is the slump flow test really telling us anything? Well, we can do that, and then we can look at the pancakes on the board, right? And we can assign some sort of VSI rating to it. And so, you know, this sort of arbitrary, it's not arbitrary, but this ranking system, right? If it's really good, we give it a 0. If it's really bad, we give it a 2. What's more interesting is how that concrete performs in the wheelbarrow, right? So after you get done pouring it on the board, why don't you look at the concrete in the wheelbarrow? Why might it be important to look at the concrete in the wheelbarrow? See if it segregates. Why is it important if it segregates in the wheelbarrow? A lot of times our wheelbarrows are basically very similar to the giant piece of formwork that we're putting into, right? So we can put it into a wheelbarrow, or we can put it into a $1 million element, right? At least that's what it'll cost when you remove it. And so we can put it in the wheelbarrow because how it's going to perform in the wheelbarrow might be similar to how it's going to perform in the formwork. The interesting thing is sometimes how it performs on the slump board is not how it performs in the wheelbarrow. So here you can see an example of concrete, and the reason why it's brown, just for context, is it's colored concrete. That wasn't apparently obvious. They're like, why is it brown? So this was colored concrete. So on the slump board, it actually doesn't look too bad. In the wheelbarrow, however, after it was sitting for 10 or 15 minutes, this is how it looks. So you can see that makes us falling apart after 10 to 15 minutes. So we don't want that to be the mixture in our formwork, do we? Mm-hmm. And ultimately, what we're trying to mitigate is segregation, right? So that when we pull the forms, we don't see this voiding at the base of our element. And so we should look at how that concrete looks as it's coming out of the chute, right? As it's in the hopper, and ultimately how it's placed. We can look at that concrete as it comes out. Okay, that looks like great concrete. So as that concrete is being poured out into the hopper, you can look in the hopper and see if that concrete is still not segregating and that coarse aggregate is still in suspension. So that concrete that we just saw now, this is the concrete that's going into that formwork. So that concrete looks pretty soupy, doesn't it? And we're all looking at it, we're like, okay, it look good on the board, it look good in the hopper, it look good in the wheelbarrow, how is it actually going to look now? You guys are really into it at 3 o'clock in the morning. 15 minutes later, the coarse aggregate is still in suspension. And so we feel good about that. That's good concrete. So remember what our goals are, right? We want to get the concrete in the forms, we want to try and cover up all the reinforcement, and we want to prevent segregation. And if we can do that, we're probably doing okay. And that's all I have.